Look down at your hand right now. That color, the exact shade staring back at you, is not an accident. It is not random. It is the end result of a 2 million-year war fought on the surface of your ancestors' bodies. A war between two invisible enemies: the sun that gave life and the sun that could kill it. Every single person alive today, all 8 billion of us, descended from ancestors who once shared the exact same skin. Not white, not brown, not black as we categorize it now. Something else entirely. Something closer to a pale reddish pink, hidden beneath a coat of dark body hair. What happened between then and now is one of the most elegant survival stories evolution ever wrote. And by the end of the next few minutes, you'll never look at skin color the same way again.
Here is what the science tells us. Every human alive shares 99.9% identical DNA. The visible differences in skin tone are controlled by fewer than 10 genes. Modern humans have been evolving different skin tones for roughly the last 1.2 million years. And the transformation from our earliest ancestors to the palette of skin tones alive today happened faster, genetically speaking, than almost any other visible trait in the human body. This is not a story about race. It's a story about geography, radiation, chemistry, and survival, written into your cells before you were even born. The ancestor under the fur. Roughly 7 million years ago, in the humid forests of East Africa, our earliest ancestors looked nothing like us. Paleoanthropologists studying early hominins believe these creatures were covered head to toe in thick body hair, much like modern chimpanzees. Beneath that fur, their skin was almost certainly pale. Pale skin protected by the shade of dense forest canopy and thick hair, much like the skin hidden under a gorilla's coat today. For millions of years, that pale skin was never a problem. It never saw direct sunlight. It never needed to defend itself against anything.
Then the forests began to disappear. Around 2 million years ago, Africa's climate shifted. The dense canopy thinned into open savanna. And a new species, Homo erectus, stood upright, walked farther, hunted longer, and for the first time in the story of our ancestors, spent entire days exposed directly beneath the equatorial sun. This is where the war began. The sweating ape. Standing upright changed everything. It freed the hands, it freed the head from direct overhead sun exposure. But it also created a brutal new problem: overheating. Researchers who study the evolution of human thermoregulation, including biological anthropologist Nina Jablonski, have argued that as Homo erectus began hunting during the hottest hours of the day, chasing prey across open plains for hours at a time, the body needed a radical solution to avoid literally cooking itself from the inside. That solution was sweat. Humans evolved to have far more sweat glands than any other primate, up to 5 million of them across the body. But sweat glands only work efficiently if the thick body hair covering them disappears. So natural selection began stripping away our fur, generation by generation, trading warmth and protection for the ability to cool down through evaporation. And that created an entirely new crisis. Bare skin under the direct equatorial sun, all day, every day, for a lifetime. The folate problem. Here is where the science becomes almost cinematic in its precision. Ultraviolet radiation from the sun does not just cause sunburn. It destroys a critical nutrient in the human bloodstream called folate, a B vitamin essential for DNA synthesis, cell division, and most critically, for a developing fetus during pregnancy. Jablonski's research proposed that early hunter-gatherers with insufficient folate protection would have faced higher rates of birth defects and reduced fertility. In a world without fur, without sunscreen, without shade for most of the day, the human body needed a shield.
and evolution had exactly one tool available: melanin. Melanin is a pigment produced by cells in the skin that absorbs and scatters ultraviolet radiation before it can damage the DNA underneath. The more melanin a population produced, the more folate was protected, the more successful pregnancies survived, and the more that population's genes were passed forward. Over hundreds of thousands of years near the equator, natural selection relentlessly favored higher and higher melanin production. This is the origin of dark skin, not a mark.
The Great Migration and the vitamin D crisis. For most of human history, that was the end of the story. Dark, melanin-rich skin dominated the human population, because for most of human history, almost all humans lived near the equator. Then, somewhere between 100,000 and 70,000 years ago, small bands of Homo sapiens began walking out of Africa, north into the Middle East, further north into Europe and Central Asia, into regions where sunlight fell weaker, thinner, and for months at a time in winter, barely fell at all. And this created a second, opposite crisis. Human skin doesn't just defend against the sun, it also uses ultraviolet light to produce vitamin D, a nutrient essential for absorbing calcium and building strong bones. In equatorial regions, sunlight is so intense that even heavily melanated skin produces plenty of vitamin D production. But in northern latitudes, with weaker sun and fewer daylight hours, dark skin blocked too much of the limited ultraviolet light available. Populations that migrated north and retained high melanin levels faced a devastating new threat: vitamin D deficiency, leading to rickets, weakened bones, and in women, pelvises too fragile. Once again, natural selection had a single, brutal answer. In regions with weak sunlight, individuals born with less melanin absorbed more of the limited ultraviolet light, produced more vitamin D, survived childbirth more successfully, and passed that lighter skin forward. Genetic studies of ancient DNA suggest this shift toward lighter skin in European populations may have occurred far more recently than once assumed. Some research points to changes still spreading within the last several thousand years, almost shockingly recent in evolutionary terms. Stop and understand what's actually being described here. This was not gentle, gradual drift. This was a matter of literal survival, generation after generation, in two opposite directions at once. Too much melanin in the north, and children were born with bones too weak to survive. Too little melanin near the equator, and pregnancies failed before they ever reached full term. Skin color is not decoration. It is a genetic ledger of exactly where your ancestors had to fight to survive the sun. The mosaic we live in today. By the time humans had spread across every continent on Earth, populations had calibrated their melanin levels to their local environment with astonishing precision. Darker skin near the equator, in Africa, South Asia, and parts of the Americas. Lighter skin in Northern Europe and Scandinavia, where sunlight is scarce for much of the year. Intermediate tones across the regions in between. And the genetics tell an even stranger story. Some populations, indigenous Arctic peoples among them, developed lighter skin despite living at extreme northern latitudes, but compensated through diets extraordinarily rich in natural vitamin D from fish and marine mammals, reducing the evolutionary pressure toward. So every skin tone alive today is a different chapter of the exact same story, adapted to a different battlefield. Not a hierarchy, not a boundary. A map, written in melanin, drawn by the sun, and carried forward unbroken in every person who has ever lived. And somewhere, right now, that map is still being written in you.